Hi there. Hi, Daniel. Hi, Shawn. Just to let you know that we're now live. So if you could share your presentation, and I will make a very quick introduction, and I will leave you to it, and I will pop back up when it's time for Q&A towards the back end. So for the purpose of the audience, the final session of today will focus on multi-phase flow meter applications in the new digital yet cost-sensitive environment. And we have our presenter is Daniel Sequeira, Director Americas Multiphase Flow Metering Solutions for Haimo Americas. And we also have Shawn Tan joining us as well. So could you share your presentation? I can see your presentation.
Having a small problem with the presentation. I think I need to restart it once.
Yep, I can see it perfectly fine.
It isn't forwarding, so I just try and restart it once. Just give me a moment.
Okay, no problem. So just a reminder to the audience, for your questions, please drop them in the Q&A box on the right-hand side. Just click on the Q&A box, and then you just type in your message and press send, and we will pick those up towards the back end.
Sorry, that's another screen. Let's start it again. Just give me a moment.
So the audience, just bear with us, please. We will.
Sorry about this.
We'll be with you in a moment.
Slow. I know it's the last presentation of the day, so everyone's about ready to pack up, so we try to keep it short and interesting. Unfortunately, we have these technical glitches on the digital forum. Really sorry about that.
No worries. Perhaps, maybe Shawn, do you want to introduce yourself, or Daniel, do you want to introduce yourself while it's loading up?
Yeah, sure. I think it just got it on now. Okay. Okay, it should be good. We should be good to go.
Yeah, I can see the presentation.
Right. So just to introduce ourselves, and sorry for that late start. So my name is Daniel Sequeira, and I'm at Haimo America, overseeing the multi-phase metering solutions. So my background is more metering. And with me is Shawn Tan, who's our digital unit manager. And between the two of us, my background in flow metering, Shawn's background is in reservoir engineering, and now more in the digital realm of things. What we provide for customers through Haimo America is the deployment of flow metering solutions, more now with the digital oil field sector. And a warm welcome, first of all, to all of you all who are listening in on this last presentation. It's a wet day in Houston. And thanks to the team at AMG for putting together this show on automation and the Automation Week. And just before we start, just to notice that, I hope all of you are keeping safe in this new normal that we're living in the way we work, in the way we have to live our lives. And automation, again, is going to play a big part of it. And remote automation, of course, is also part and parcel of our daily lives now, given the conditions we live in. So moving on, we've had some very good panel discussion, and the last presentation specifically on the application and production optimization really leads into what we want to present today, which is actually on a specific tool, which is the multi-phase meter, and how that can help operators in their goal for production optimization. And how does it compare to legacy systems, and how do we get to that point, and why is it actually really necessary when we're talking of the new digital or the smart oil field? So looking at the slide that we have on, so this is more of an introduction where digital transformation has been the trend, and we've had it for a number of years in the oil and gas industry. But in recent years, of course, it's picked up that much of impetus. And we see that in different spheres, whether it's the engineering designs and the automation or the data collection or processing systems or the analytics platforms that we have, the cloud-based platforms. And the reason behind the increased demand for digitalization obviously is the value that an operator gets out of it. And if I put it very plainly, it's the bottom line. For an operator, it's the bottom line in terms of his operational and his cost efficiencies. And even for us as manufacturers and suppliers and partners and supporters to the oil and gas industry, is the bottom line in terms of the solutions we can provide at the cost that we can provide it, and how can we help our customers and the operators get the best deal out of it. So when you talk of sensors, you've got flow meters, you've got pressure, temperature, vibration, a number of sensors in the oil field, right from the wellheads and into your flow lines also. And all these sensors feed into your systems, be they Sequeira or be they the higher end digital systems. But what's more, in terms of the frequency of data that you get, you had a lot of the standalone sensors like pressure, temperature, vibration, etc., that really have picked up in terms of the frequency that can provide high quality data. But what about the production systems and flow measurement? When we look at a traditional systems of a central processing facility with the test separators, do they really meet the digital transformation expectations? And that's what we'll look into it today, and how multi-phase meters play a part in it. So we look at the facility, we look at the technology. Obviously, why do we want to talk about multi-phase meters at this digital forum? The applications that it has in completion as well as in production, so it's the whole life cycle of the well, and a sort of a summary and a conclusion. So this is a snapshot of a traditional production facility, one of the options where you could have the central processing facility with a traditional per well measurement. And what you can see is that you have your three-phase separators on each and every well, and then you have the individual single-phase flow meters going into the tank farm and the LACT units. And some bullet points on this is that the data that you get out, because this is a separation-based unit, so this is periodic data, it's discontinuous data. The footprint is oversized. This is more to do with the cost of the facility. You've got piping that can also, redundant piping, and add into the cost of the facility. So CapEx is more. And relatively, it's more maintenance prone than the modern systems. Another option that people would go for on a central processing facility with the traditional measurement is you could have a tester in the field. But the issue with the tester is that it's again intermittent data, because you pick and select the wells that you test, and maybe you just back allocate the production to the other wells. Flexibility obviously is very low on this. So when you look at the frequency, the accuracy, reliability of the other sensors that we use on our wellheads and in our oil fields, can the production meters or the sensors in the traditional case and the measurement accuracies, when we're talking about three-phase separator, really meet the requirement for real-time production monitoring, for flow assurance, for diagnosis, and the other digital requirements that we're talking about on this forum? And from our side, if you have, we may be a bit biased that we are the manufacturers or the solution providers, but even if you look at it generally, in most cases, the answer would be no when you look at the whole picture. And the question begs, can we do better? And that's where we come in with the multi-phase metering technology. And just a little explanation for those who are maybe not familiar with this. So the meter, when we talk about multi-phase flow meter, it actually is a unit or a tool or an equipment that provides for the continuous flow measurement of oil and gas and water, just like a test separator. But the important factor is that without the phase separation, and this is really real-time data. And you have variations of that in terms of a wet gas meter, or you could have a sand meter, or you could have, maybe a meter with two venturi units, so different variations. But the core philosophy is the multi-phase flow metering philosophy, which we'll just get into in a bit. So this is in the nuts and bolts of a meter, and I've just kept it to one slide. Of course, if you need additional details on how the meter actually works, because this is not a metering seminar, this is more on the digital side, but you can always visit with us on the booth, and we'd be glad to share with you. But, in a very brief way, the core components of the meter are the venturi, which is there for the flow, and you have a dual energy gamma sensor, which is basically for the phase fraction measurement. And then you've got a standard multivariable transmitter, which gives you your pressure, temperature, and differential pressure. So you have the total flow rate being measured by the Venturi, and the gas volume fraction and the water liquid ratios is by the gamma ray system. And then you have the oil, water, and liquid flow rates calculated. Now, the equation may look pretty simplistic, but of course there's also models that go with that, and then you can have PVD equations at the back of it. But ultimately, this is just to give you an idea of how the multiphase meter works, because what we want to talk about is more the benefits when it comes to the digital oil field by using these meters. So why are they the better alternative? The meters actually provide more value and they really fit better in today's data-driven environment. For one, you get the high frequency data, and that's an absolute must. When you look at the other sensor data that's coming into your Sequeira systems or into your computational systems, if you have one system which is a traditional legacy system of measurement, which is giving you data at a slow frequency, you really can't do all those computations and get the value out of your data. So when you use the multiphase meter, you're getting high frequency data, and that matches with the frequency that you get out of your other sensors. And again, in terms of communications, the data that you get out of a multiphase meter, the integration is across all systems. It could be a traditional Sequeira system, Modbus, Fieldbus systems, because it basically works with, the data is coming out through Modbus or TCP, IP, Ethernet. And the remote operational capability is there with it, which is something you may not get with the legacy system, as well as what's very important is the diagnostics and the service capability. So when you're talking of digital oil field, rather than have people go out in the field every time to check on your meters when it comes to a single phase meter, when you have the multi-phase meters, you can, first of all, see this data, even in the comfort of your office, on a bedroom, on a mobile phone. But actually, when you want to do the diagnosis, or if you feel that there's something going wrong and you need to look into it, you can work with a vendor or have your own people trained that you can actually dial into the meter and actually set things right to a great extent remotely without having to take the effort and the QH is at risk of people going out in the field to set things right. Now, you're actually monitoring 4 phases by using both the sand meter and a multiphase meter. Like I said, the sand meter is just a variation of what we have as a multiphase meter. So you can actually manage to monitor all the 4 phases, which is your sand, your oil, your gas, and water rates. And that is obviously a very big key to your reservoir management and production optimization. Your real-time data is you're getting accurate data, and that's fundamental, again, to smart field development. So when you look at a gravity-based dissipator, you just can't get that real-time data out of it, which you get out of these meters. When you look at the size of these meters, you look at the footprint, you look at the weight, these are, again, much smaller and much fewer components, less maintenance prone. And coming to the important part, which is there for all operators in terms of, what's the value for money. So, we won't go into numbers here, but it's when you looked at multi-phase meters in the history, and I come from a background of the Middle East, and I moved to North America for my Middle East operations, and been with the company for the past 20 years. So I've seen how the whole history of multi-phase meters has progressed over the 20 years I've been with this one company. And earlier to that, since I have a background in control and automation, I've been doing a lot on single-phase flow meters too. So when you look at it, ultimately the bottom line comes to, do I really get value for money out of these new systems? And when you, earlier especially in North America, the multi-phase meter was more considered to be something that you use offshore and subsea because of the high cost of procurement. But with the advances in technology, it's across the board. It's not just one vendor, but most vendors today can give you a solution that's very competitive in terms of how it compares with your legacy and traditional systems. Just to go over the advantages again, it's an inline meter. So you've got no moving parts. So it's low OPEX and maintenance. Again, that leads to safety because it's less of QHS. You have less people you need to go out to the field to look at these meters. Flaring, which is now becoming even more important, and regulations coming in. So there's no phase separation. So it's a zero flaring meter. These meters can be installed right. You get the high pressure meters, 5,000, 5K meters, which can be installed at the wellhead, or you could have maybe a 300 class or a 600 class meter installed in a flow line. So it starts. You can use these meters right from, for example, a sand meter right in your completion stage would be when you're doing the drill out, when you're doing the flow back, and then right into the production stage where you need a meter like a multi-phase meter, which goes on into the lifespan of the entire life cycle of the well. A small footprint, it has simple installation, and there's it's a safe operation, obviously. High mobility, low pressure loss across the meter, low power consumption, all big pluses when you look at technology. And then the reliable high frequency real-time data, the accuracies, where you're so used to having the traditional systems and accuracies of 10 to 15% on the phases on the overall system as such, although you do have single phase meters. But the system as such, when we talk to most operators, they're quite happy with the 10% on the test separator. But you're also going to get much better accuracies in terms of your phase fractions when it comes to a multi-phase meter. So that's a big plus too. So just to give it in a sort of a picture, and I guess most of y'all would have seen these pictures in the field. So you can see the comparison when you look at the size of the test separator against a multi-phase meter. And what we have in the lower right corner is actually the meter on a flow line, right at the wellhead. And the difference in size, the difference in terms of the actual capex and opex that go into the installation is huge, because this is not a pressure vessel like the separator, so you've got much less of the regulation hazards also. Yes, it does use a gamma source, but it is enclosed in a lead capsule. There's a high level of safety with that. And incidents with gamma sources with the multi-phase meter in the field, are pretty rare in the 20 years that I've been working with multi-phase meters. So safety aspects, we pay a very high level of attention to the safety aspects too. Applications are both onshore and offshore production. You can have them in various configurations. So you've got a sand meter, you've got the wet gas and multi-phase meter, or if you've got rangeability issues, you can even have 2 meters in one in terms of a skid. Wide ranges in terms of the capacity and their operational ranges. And this brings us back, we saw the earlier slide where we showed the central processing facility with the individual well test separators. And this is what we'd like to project, and this is something we've done with clients here in the Permian too, where you have a single meter on each wellhead, which replaces those 3-phase test separators. And the value that clients can get out of this is huge. So one, you're replacing the test separator with the equipment that does not require separation, right? You're getting continuous real-time production rates. You can even have them with a water cut meter in series if you want to cross-check on the water cut also. So all in all, great savings in capex and opex. And a rough estimate was that you can have through the operating, the cost could come down to more than 40% over the life of the lease actually. This is something just to show you how and this is again custom built, so it can change from operator to operator, and it's very flexible and adaptable. But this is the HMI or the MMI, so you can get a graphical representation of the high frequency data. You can see just by the graph that it is high frequency data, because when you normally see a well test graph, you'll see a pretty smooth line. But just by looking at these graphs, and you can average this out to whether you want it every 15 minutes or you want it an hour or you want it per minute. But the default is normally a per minute data. But the meters actually, the frequency is in seconds or milliseconds is actually the acquisition frequency. But for the human eye, just to show the data, it's shown on a per minute basis. But you can smooth out these graphs over an hour, over a day, and really decide what do you really want to see. Do you want to see, maybe if you're a reservoir engineer, you'd like to see it on a per minute basis. If you're the operations or the production manager, you maybe just want to see the hourly basis. But it's on Excel, so you can work on that, and it's easily adaptable to whatever type of HMI, MMI you want to see, and which is useful to you in the field. This is just one slide in terms of a real field example where in the Permian Basin, where the meter was run and the errors that you get are very close to what we actually get in the lab. When we specify these meters, you talk of a 5 to 10% accuracy on the gas, 2% plus minus absolute on the water cut, and about a 3 to 5 on your liquid. But when you go out on the field, you could be surprised, and we were surprised ourselves, that sometimes you can get as close to your third-party lab accuracies even in the field. And this is just one example of the same. If you go one step behind the production, whereas you first have your completion application, and you're talking of drill out and flow back, I just want to touch on a sand meter. And a sand meter is a variation of a multi-phase meter. Again, you're looking at the use of a digital tool in the completions operation during drill out and flow back, where when you want to quantify the amount of sand that's coming out of the well at an early stage, and you want to take those optimization decisions on the fly, You don't even want to wait till you collect the sand and wait, and you know that, there's too much sand coming out, or there's something going wrong. With these meters, be it a sand meter, be it a multi-phase meter, since they give you data real time, what you see is whether it's a question of adjusting the amount of propane that you're putting in it, or you want to measure the sand, or if you're even doing choke optimization, you can do it on the fly because what you're getting is real-time data. You have the data, you can see it as the operation is going on, and you can take corrective action immediately. So this is more a case of being proactive rather than being reactive after the fact. So just to conclude, and I rushed a bit through it, but like I said, you can always drop by our booth and we can always entertain the detailed discussion over there. But since I started a bit late, and the conclusions of when you look at it, or a summary, is that in the current data-driven environment, multi-phase meters provide enhanced data for better flow assurance, troubleshooting, and understanding of your well conditions. They are a better option than the legacy equipment in terms of the data availability, your frequency of testing, CapEx, OpEx. There's also a host of safety and ease of operation features. They not only save you time, but there's so many other benefits that we saw in the previous slides. And something that we've not touched in this presentation, but it's also something that most multi-phase meter vendors would provide, is that when you combine the multi-phase meter data along with other software that goes with it in terms of the artificial intelligence and other add-on packages like the virtual flow metering, you can actually detect and determine your flow stability that you can actually see with legacy products. So what happens is that you can even reduce your testing time, which is a big plus. So you could go down from a 24-12 to maybe even a few hours on the test on the well, which gives you that much more frequency of testing, that much more data to deal with. And the more data you have, the more you can study, the more optimization exercises you can carry out. We talked about the sand meter, which is a plus during your drill out and flowback operations. And when you look at the value delivered from the technology, this is an enhanced digital solution for completion as well as production operations. And it gives you tremendous cost savings. It gives you, like I said, I can't, the many times I repeat it, but I think the high frequency data is key. That is really key when you compare this to any other equipment that's giving you your well data. And that aids in the real-time decision making. And as a plus, you also get the HSE risk reduction, and you get much better options for your production management. So that's for the presentation part. I'll just have a look if someone's come up with questions, and we can take those on. So there's a question by Jared, which says that, is the meter production allocation quality acceptance? Well, it's a good question. So when you look at multi-phase meters, I think what we need to be very also open about, and we believe in sharing on the technology, is that these meters are not fiscal meters, but for sure they can be used for production allocation in terms of the accuracies. There are various standards that are there in terms of the meter, in terms of the API recommended practices and other such stuff. But while they are not fiscal meters like single phase, when it comes to production allocation, that is more an agreement between two parties. And as long as the accuracies are set and the meter is accepted, we've had examples here where the operators and the service provider can talk to the RRC and they come out with an acceptable agreement for the production allocation. So yes, to answer the question, it is a meter that is used for production allocation in terms of the quality, and it is accepted as a production allocation meter. I don't see any questions, but
if there are any more questions, please, we'll leave it another 30 seconds or so. So if there are any more questions, please drop them in the Q&A box, and we'll just pick the questions and we'll read them out and respond to them. But just a quick reminder as well. Haimo have got a virtual booth. So once again, you can go meet with them face to face. Go meet with the rest of the team. All you have to do is, if you look on the left-hand side of your screen, there's various tabs. One which says exhibition. Just pop in there, and you will see their booth. You can pop in. You can schedule a meeting face to face. You can pop into the room and have a conversation. You can pick up materials. You can download videos. There's loads of ways for you to connect. But like I've said all day, to the audience, ultimately our sponsors are here to help solve some of the problems that the industry faces, and certainly trying to develop solutions and offer ways to help overcome those challenges. So please do take the time to meet with them. It doesn't appear as though we've got any more questions, guys. So is there anything else that you would like to add or to summarize the session or to sum it up?
Well, just to say thank you to the audience. There weren't many questions, but it was the last session of the day, so I expect more maybe at the booth. And like you said, Shawn and I and the others are there at the booth to handle that. Thanks again for organizing this session, because I think this is the end of the upstream session, where we as manufacturers actually have products that apply. And all the best for the session tomorrow. So we'll see you all there.
Absolutely. And you'll be with us tomorrow as well?
Yeah, we will. We'll
Absolutely.
join.
So again, to the audience, there is also a functionality where you can schedule a meeting. So if you don't have time to catch up with them today, just click on the button and you can actually pick a time to sit down and meet with the guys face to face. So, but on that note, thank you very much to Shawn and thank you very much to Daniel.
Thank you, Mark. Thanks.
Taking the time out to present and prepare the presentation. Very insightful. And that concludes the presentations and the discussions for today. So before you all head off, again, the platform remains open. So these events are great for learning, and that's what you're here for. But there's also the opportunity to network as well. So whether you're stopping by a booth or you'd like to drop into a table, engage with somebody through a messenger service, please feel free to do that. Otherwise, once again, thank you to everyone for attending. Thank you to all of the sponsors, all of the speakers, and I will look forward to seeing you all tomorrow at 9 a.m. Central Time. Have a good evening. Thank you very much.